Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of U substitution. Typically when we're integrating, we're first going to try to do them separately, and if they're connected together with a high exponent or under a radical or something like that in a denominator and you can't separate them, and you try to do algebra, long division, separating numerators, stuff like that, and that doesn't work, or it's a trig problem, you try some trig identities, you can't rewrite it anyway, then you try your first ace up your sleeve, which is U substitution. In U substitution, what's going to happen is we're going to rewrite the problem in terms of another variable, and upon doing this, the problem should be much easier. I mean, really much easier. The criteria is that you have to have the derivative of one part of the problem present in the other part of the problem. Again, the derivative of one part of the problem must be present in the other part of the problem. So what you will do is you will assign u to one part, and then the du will cancel out, and you will integrate. So here, for instance, x squared plus 1 would be your u. It's the more complicated expression usually, and the derivative of an x squared term is an x to the first term. I don't care about numerical coefficients. Numbers in front don't have to be the same, just the same number of x's to the same power. If I were to look at this one here, x squared is indeed the derivative of x cubed inside. Derivative of tangent is secant squared. Derivative of 1 is 0, so that would work. All these are U sub problems. There should be a dx right there. Not a big deal. Here, derivative of x squared is x. Hopefully you see the pattern. Derivative of ln x is 1 over x dx. So in all these, U substitutions applicable. Okay, again, you're going to set u equal to one part, derive it, and get the other part. Okay? And everything should cancel out. If everything doesn't cancel out, in terms of the new variable, then you either did something wrong or you can't do U substitution. There's one exception to the rule. I'll show you that in probably the intermediate example video, or advanced. But there typically should be a way to get rid of all the old variables. I tell people, think of U substitution as letterist. It's like, I'm not going further until I get rid of all these x's. It's got to be all U's in here. I know that's silly, but considering the times we live in, it might be a little applicable. So if you have some bounds and you're doing U sub, you also have to change your bounds in terms of U. And the way you're going to do that is you're going to substitute for x, whatever the x numbers on the integral are originally, in terms of your U equals expression, and then you'll get what U equals. I'll show you all that in the example videos. I hope I've clarified the concept enough for you to practice some problems. It's not too bad once you get the hang of it. It just seems overwhelming because it's new, and most things that are new people are afraid of. So conquer your fears, practice as much as you can. Thanks for watching. Have a great day.